So students, our next topic is measuring mass. So before we start, try to understand definition of mass. Okay, the mass of an object is the amount of matter contained in it. More the matter in a substance, heavier it is. Okay, so the mass is the amount of matter in a body. Okay, mass is a property that does not change with its location or shape. Mass is a constant quantity and it will not vary from place to place. Okay, the SI unit of mass is kg. So this is all about mass. SI unit of mass is kg, and some other units of mass like mg means milligram, gram, kg. These are the different units of mass. Okay, some important relationship between the units of mass. So please try to understand that important relationship. Means 1 kg, 1 kg is equal to 1000 gram. 1 kg is equal to 1000 gram. This is the first relation. Okay, 1 gram is equal to 1000 milligram. So these are the important conversion. First one is the 1 kg is equal to 1000 gram and 1000 is equal to 1000 milligram. Okay, 1 pound. Pound is a also unit of mass. 1 pound is equal to 453.59 gram. 453.59 gram. This is the another unit of mass. Next, quintal. 1 quintal. 1 quintal is equal to QUINTAL. 1 quintal is equal to 100 kg. This is the next conversion. And 1 ton. 1 ton is equal to 1000 kg. So this is all about units. 1 kg is equal to 1000 gram, 1 gram is equal to 1000 milligram, and here 1 quintal is equal to 100 kg and 1 ton is equal to 1000 kg. So this is all about mass. Mass is the amount of matter contained in a body. Mass is a constant quantity. It will not varies from place to place. SI unit of mass is kg. So the next is weight. Okay, weight. The weight of an object is the gravitational force or gravity acting on a body. The gravitational pull acting on a body known as weight. Okay, weight is the force, so its SI unit is Newton. The SI unit of weight is Newton. The direction of the weight is downward towards the center of earth. Okay, the SI unit of the weight is Newton. And one difference between, there are so many differences between mass and weight, and one most important difference is weight varies from place to place. Means weight dependent upon the gravity, which we will see in the next slide. Okay, so this is the difference between mass and weight. Weight is a gravitational force acting on a body, and the SI unit of weight is Newton. So this is all about mass and weight. Okay, relationship between mass and weight. Okay, the weight or gravitational force acting on an object is dependent on its mass. More the mass of an object, greater the gravitational force. As well as mass of the object will increase, the gravitational force will increase. So here we have formula: weight is equal to m into g. W for weight, m for mass, and g for gravitational field of strength. Okay, so g means gravitational strength varies from place to place. Okay, means it varies from 9.8 to 10. This is the variation of gravitational pull. So this is the relationship between mass and weight. W is equal to m into g. W for weight, M for mass. As well as mass of a body will increase, weight of a body will increase. Okay, so this is all about mass and weight relation. So here we have difference between mass and weight. Okay, first of all, mass and here weight. Mass is an amount of matter contained in a body, and weight a gravitational force. In the first point, we can write the definition of mass and weight. Mass is an amount of matter contained in a body, and weight a gravitational force acts on a body. So directly we can write an amount of matter contained in a body, a gravitational force. Second, mass is a scalar quantity and weight is a vector quantity. About scalar and vector quantity we will see in next class, but here you can understand scalar quantity means in the quantity where it is only about magnitude, and in the vector quantity it is about magnitude as well as direction. The quantities which contains only about the magnitude, like 32, 40, 60 means numerical value are also known as magnitude, and vector quantity means 30 kg or 30 Newton in downward direction, 40 Newton in upward direction. So this is related with direction. Okay, next about unit. SI unit of mass is kilogram and SI unit of weight is Newton. Next, independent of the gravitational field of strength, dependent on the gravitational field of strength. Mass is independent on gravitational strength, means it will not vary from place to place, and weight will varies from place to place because it dependent upon gravitational strength. And the last one, measured with a beam balance or a cantilever measured with a beam balance or a calibrated electronic balance, and here measured with the spring balance. So measuring devices for mass, beam balance or electronic balance, and for weight, spring balance. So this is all about difference between mass and weight. Mass is an amount of matter contained in a body, weight gravitational force acts on a body. This is the scalar quantity, weight is a vector quantity, SI unit is kg, SI unit is Newton, independent of gravitational field of strength, dependent on gravitational field of strength. Next, measured by the beam balance or electronic balance, and here it can be measured by using spring balance. So this is the difference between mass and weight. Measuring mass with a beam balance. Beam balance is a device by using beam balance we can measure the mass of an object. Okay, so first of all we shall try to understand the definition of the beam balance and then principle and working of the beam balance. Okay, so we'll see one by one. So we shall start with basic construction of beam balance. Beam balance is one of the simple instruments that you might have seen at a grocery shop. A beam balance consists of a horizontal metallic beam with a support and a pointer at its center. It has one horizontal metallic beam with a support and pointer at a center. Okay, the beam can move freely about the support. From the end of the beam, two similar pans are supported such that they are equidistant from the center. There are two similar pans which are equidistant from the center. Equidistant means same distance from the center. So this is all about the construction of a beam balance. It has two pans. These two pans are similar. One horizontal metallic beam and pointer at the center to see the level of balance. Okay, principle. If both the pans have a same mass, in this case a beam will be horizontal and the points exactly vertical. This is the exact principle of beam balance. Okay, working. To find the mass of an object, it is placed on one pan and standard weight are kept on the other pan. If you have to find the mass of an object, so we can keep object on this side and or this side, and we will keep one by one standard masses like 5 gram, 10 gram, 20 gram, 100 gram, or in kg 5 kg, 10 kg, 20 kg. It is for the bigger masses, and 10 gram, 5 gram, these are used for small masses. Okay, the weights are adjusted till the beam is horizontal. One by one we'll keep the masses here, different masses here, different standard, and then we have to measure with a object. Okay, when the pointer points vertical, when the pointer points exactly vertically up, the sum of the masses of the standard weight gives the mass of the object. Ensure the following points to get the accurate reading of mass. So these points will use for exact mass. When this pointer will points exactly vertical, when this pointer points exactly vertically up, then we can say it is a state of equilibrium. Okay, so in this case we can tell the exact mass of an object. Okay, measuring mass with electronic balance. For scientific purpose, where the measurement should be accurate, we need highly sensitive instruments. Okay, nowadays electronic weighing machine with digital display also being used in laboratories and shops. Due to their high degree of accuracy in measuring mass, different objects, especially small objects, can be measured by using this. This machine gives the mass of an object to the accuracy of gram and milligram instantly, and hence these machines are reliable also. For example, an object whose mass shown 3.550 kg on electronic machine tells us that the mass of the object 3 kg and 550 gram. Before measuring mass with electronic balance, it is important to make sure that the instruments are working properly. This can be done by making sure that the device shows zero reading when no object being placed. So the most important thing is, please be careful in our daily life also. Before measuring with the beam balance, it is very important to ensure that your electronic balance or your electronic meter showing zero reading. When you will see an electronic balance, so there are some readings already given in the electronic balance, so it should be 00 when there is no object kept on the electronic balance, which will be helpful in your daily life. Okay, for example, beam balance, the two pans should be balanced when nothing is being measured. Similarly, an electronic balance should be show zero reading when nothing placed on it. As beam balance, if nothing kept on the beam balance, it shows exactly vertical pointer. Okay, when no object kept on the electronic balance. Suppose this is your electronic balance device and there is no object kept on the electronic balance, so here it should be show 00 reading on the object. So electronic balance is a device which gives us accurate reading, and we can measure small as well as large object by the electronic balance in grams and kg. So electronic balance are the standard measuring device which we are using regularly in our life. Okay, so this is all about electronic balance.